So I'm a behavioral scientist, and I study how people use genetic and genomic information to make decisions about their healthcare, how people understand it in communities, and how we might expect the future of genomic technologies to affect patients, providers, and communities as well.
I'm a pediatric geneticist, meaning I'm a kind of doctor that takes care of children and other people who may have or may be suspected to have genetic conditions. My research group mostly focuses on using artificial intelligence and certain types of artificial intelligence to try to better understand genetic conditions. For example, the different manifestations, the different features that a person might have with genetic conditions, and to better analyze data sets so that we can diagnose people faster and more accurately and hopefully figure out the best possible treatment for people affected by these conditions.
I'm a physician scientist. I work at the National Institutes of Health. I work with families who are affected by rare genetic conditions, and we study those diseases to better understand their nature, what causes them, how fast those conditions progress, and we also work with families to develop new treatments to improve their lives.
So the good news about artificial intelligence and machine learning is that the titles, artificial intelligence and machine learning, kind of explain what's going on. The bad news is it doesn't really do it well or capture all of the complexities. But for really short purposes, artificial intelligence means using computers and training them in a way that they can think intelligently so that they can do tasks that normally we would think a smart person would be able to do. Machine learning is a subset, it's part of artificial intelligence. And in machine learning, a machine can learn without being specifically told what to do, so it can kind of get better on its own.
So, and I think a reason why that's important here is that by using machines, we can find patterns in data that, as humans, we might not be able to find as well using our traditional methods. So machines are very good at taking big masses of data and finding the patterns among lots of variables and lots of pieces of information that we've traditionally not been able to find.
I prefer to think about machine learning as a massive calculator. It's a calculator that is able to do calculations on its own, and a lot of those calculations, and look for regularities among numbers. It looks for symmetry in the data sets, and by finding those regularities in the data sets, it helps us find rules. And once we find rules, then we can take advantage of applying those rules to understand what causes the diseases, find chemicals in blood that are linked to manifestations of the disease, how severe it could be, how often the patient can end up going to the hospital. And also it helps us to use this information to develop new treatments. Again, because we can find those regularities in the data sets. And the question always then comes up, well, why do you need to have a calculator? Can't you just do it yourself? And the problem is now with the amount of information that we can get from new genetic technologies that are available to us, the genetic technologies produce an enormous amount of information that I think any single person or even a group of extremely talented people working together will have difficulties making sense out of this. So by working in tandem together with fast calculating machines, we're able to find those regularities, and then as teams of investigators look at those new patterns that are found in the data sets, we're able to make use of those numbers.
So we use terms like artificial intelligence, which makes us think of human intelligence, or one subset of artificial intelligence. We talk about neural nets. There's different types of neural nets, but we use a lot of these words that are derived or related to human intelligence. And a computer might be acting in a really intelligent way, the way we would think of as intelligent. Like it can make a diagnosis really well looking at a picture, or it can synthesize a lot of data really well. But the way it's being intelligent even though we use words that sound like human words, could be really different underneath the hood. So it's not thinking, if we use thinking loosely, the same way that we're thinking, although it's doing amazing processing and making amazing decisions based on that.
Why we're better together.
Yeah.
I think there's some misconceptions about how good it is. I think for the most part, these models tend to be built for a very specific purpose. Kind of what Oleg was saying, they don't generalize very well. The computers aren't ready to take over the world quite yet. They tend to be used for very specific purposes and do well at that. However, they're getting pretty good. You guys have probably seen the AI art tools that are out there. I think one of them just won an art competition. Yep. And so in that, one area, it's doing amazing stuff. But if you were to go ask it to do something else, that probably wouldn't go very well.
I'd follow that up by that, for example, that art thing, which I've been playing with and everybody's been playing with. It's really fun. There's lots of different versions of it, I guess you could say. But one amazing thing is how quickly it's advanced just in the last year or so. A year ago, we were amazed by stuff that was relatively much more basic than it is now. I think another misconception is the fact that AI is this brand new thing and, we've only had it for a little while. And a lot of the principles behind AI and different types of AI were actually developed decades ago. And certainly it's way more powerful now because we have better computers. Like you said, we have better data sets, but it's really not a new thing. It's been around for a long time. It's only now because of these big computers and data sets and algorithms and what we call the architecture of the AI that's been worked out is that we're able to use it for things like creating art or doing medical type investigations as well.
When I think about limitations of AI, I often reflect on my experience of interacting with Siri while I drive. And if I ask it to take me somewhere, I think there are quite a few things that Siri still has to learn, or any of the assistants that are available are out there. And I think we understand that intuitively, the gap that exists out there. That we're not only talking about difficulties of AI systems to contextualize, to understand what to do with the knowledge that's being generated by these systems. We often refer to this as a problem of AGI, artificial general intelligence. But I also think there are quite a few things to be done in terms of really take full advantage of what natural language processing can do for us. Sometimes it actually makes me wonder whether we as humans sometimes need to also adjust to the limitations of what AI and machine learning can do. And just like I think our society has been evolving around what internet had become now, and it's not just we stayed the same. We changed quite a bit in how we interact with each other, what we do with those technologies. I think the same thing will probably be happening as new opportunities and new technologies in AI and machine learning are being developed.
I think we are adapting. I think about the way, when we first got some voice recognition tools, my kids would be like using completely natural language and thinking that, this machine is going to understand them. But now they'll walk up to it and say, Siri, this, because they know how to interact with machines. So it's sort of interesting to see how we as humans are sort of doing that on the other end. It's practically invisible to us now. It forms the backbone of so much of the technology that we interact with. And what we're doing is just such a little slice of AI and machine learning.
If I was going to take kind of that question and be more specific, just medically, I guess just that's what I tend to think about. I think it can do a couple things already, and it's getting much better. One is it can make diagnoses, or I should say help, like you pointed out, help make diagnoses more accurately. For example, take a geneticist, and I'm an okay geneticist, but take the best possible geneticist. Even he or she will not know every single genetic condition that they might encounter, right? So it can help supplement trying to figure out what's going on with a patient. do things more efficiently, and just like you said, be able to look at lots of data much more quickly than a person can, trying to go through textbooks and Google and so on and so forth.
Yeah, I definitely see the role of these applications in decision-making support. And we've been using these technologies for quite a while, since the beginning of search engines. We've been looking for information. We would enter key symptoms and findings, trying to find the best match for the diagnosis. I think the bigger task is how to integrate those systems into our healthcare system so that it becomes less intrusive, that it's intuitive, and it's actually helpful. And I think that's where we'll need many talented people who will exist in that, who can close the gap and bring those technologies to help patients and help doctors and other healthcare providers to improve healthcare outcomes.
Yeah. I think it's a great point. I feel like there's so many examples where as a proof of principle or in a paper or an experiment, it works and it totally destroys the person. It's so much better. But when you actually try to use it in real life, then you realize, wait a second, this doesn't quite do what we wanted, or it actually kind of messes things up a little bit just in the workflow. So I think a huge part is the integration and actually implementing it and making it be a helpful thing.
You also mentioned there's something very important, is that when I was a pediatrician, I think if I knew, like, let's say 20 or 30 or 50 diseases and be familiar with how to recognize them and treat them, I would be a very effective pediatrician, because that would probably cover 95% of patients that I would see in pediatric practice. In my field of clinical genetics, we deal with very rare diseases. There are some conditions that you may have maybe 1 or 2 or 3 people in the entire world. It is very difficult to train specialists to recognize very rare diseases if the possibility of them seeing that patient is next to 0. So because of that nature of our subspecialty, we have to rely on massive databases and search engines to piece those things together, to recognize symptoms that can actually lead us to the right diagnosis. And that's why I think these technologies are here to stay. We need to learn how to use them better. And so it's kind of, now part of our practice, how to use all these different genome browsers and OMIM or your favorite search engine to find the right diagnosis and treatments and connect those families with providers who are leading experts in their fields.
And I think that also plays into some of the work that we do. So I lead the immersive simulation program, which is a lab that helps people integrate mostly virtual augmented reality into their research, other tools as well. But if we wanted to, say, take a very rare case and integrate it into a simulated clinical encounter, maybe for training or maybe for research, sort of to understand how these very rare clinical encounters might play out. There's many ways we can do it, but one of the sort of upcoming leading ways is to have an artificial intelligence behind that simulated virtual patient, for example, so that it may be able to answer the questions in a way that's consistent with a rare disease or really any disease, and be able to sort of role play or interact with a medical student or a research participant or things like that. So, I think in the world that I come from, in terms of these technologies, AI is ramping up like you wouldn't believe. And then we can use machine learning on the back end to look at some of the data. So if I'm interested in, how much did Oleg over here look at our virtual patient as he was talking with her, and then I want to sort of try to generalize that and see, well, is there something we can learn from all of the body movement of somebody in these simulations? A machine learning approach is a really great way to deal with all that data and see if the way that you're moving around or behaving or what you're saying, if that can help us to predict outcomes, say of a visit, or how much patients are going to be satisfied, with that approach or things like that. So, I think these two things really do come together in that way.
Rare patients can be so rare that inherently part of the problem is that how to recognize that rare disease in an ethnic group or age group where some diseases can be so devastating that some patients may not even survive. So I think there are tools that are now available, and Dr. Solomon and his lab are working on those tools is to help us close the gap. And I was wondering if you could elaborate on it.
Yeah, no, it's a great and difficult and complicated question, like a lot of it, but I guess I would make a couple points in response. So first is, as you said earlier, Susan, it's so much has to do with what data you put into the data set to train your models. And so by intentionally realizing, look, we need representation from as diverse groups as possible, you can very intentionally make the system work better, the model work better for a much wider range of folks. But just like you said, even if you try to do that, there might be only 2 people in the world you know that are affected with a certain condition. And you would hate for the model to work much worse for those folks than for people who are affected with a more common condition. So there are some methods, for example, zero-shot learning, a specific I guess, type of artificial intelligence that try to learn from a large data set and say, how can we apply what we figured out over here to things that we know or recognize to things that we haven't seen before. As you can imagine, that's much harder to do, but there are methods that seem to do that relatively well and are actually being applied in the context of genetic conditions and very rare genetic conditions. But I want to emphasize it's much easier said than done.
So can I go TV? Okay, so I think in a lot of the circles I travel in, the show Black Mirror tends to be sort of one of the touchstones that we refer back to. And there's a particular episode which is basically, I don't want to spoil it, but I kind of have to because it's a simulated, an app that basically tells you how you're going to click with another person based on machine learning. I think it's called Hang the DJ, I believe, is the name of the episode. It basically shows how machine learning works if you watch it. And basically it's simulating the same event over and over and over again and looking at the outcome. So that, I think, while the app that they're talking about is probably not something that could be designed today, the process, I think, is illustrated in a really cool way.
I guess I'll go next. I would say that Terminator is real. No, I'm just kidding. Sorry, that's a bad joke. But I'm gonna go with TV. I'm gonna go with TV as well, and not because necessarily artificial intelligence or machine learning is accurate, but the show Silicon Valley, which is a comedy show that was on HBO, I think in a lot of ways depicts what's called artificial intelligence, Silicon Valley, biotech startup ethos pretty accurately, eerily accurately in a lot of ways from when I was interacting more in that part of the world. And I believe when the show started, its initial plot was this machine learning algorithm that was designed to do all fancy stuff and help those folks take over the world. But it's a very funny and sadly no longer on show.
I wish Wall-E and BB-8 would be the right answer of what artificial intelligence looks like, but it's probably not the right answer. Although I would like to use the the illustration from Star Wars, and it's K2SO, right? There's a very interesting moment there in the movies in one of the episodes. I think it's Rogue One,
right?
One,
oh, yeah.
right?
That's my favorite Star Wars
movie. Yeah. Because I think there's an interaction between K2SO and a pilot, and they're trying to calculate or figure out the risks of jumping into hyperspace from their particular situation. And K2SO says the probability of us dying is like this, 80%. I don't remember the precise numbers. And then the human operator, the pilot, says we're just gonna do it and see what happens. And I think this is where this collision of the artificial intelligent world and how we intuitively interpret and act on information that we perceive, we don't know why we do it, but we feel like it's the right decision, and we just do this intuitively. This is what I think kind of captures the essence of us human being making some of these important decisions, as opposed to a machine which will struggle. They will have to deal with numbers and will give you the probability of something, but you still have to set the threshold of when to act. Is 80% chance of achieving the result good enough? Is that a go or a no-go? again, I think that moment kind of captures of the dilemma that we're dealing with when we work with these complex systems.
Yeah. So I will admit that I've watched every Star Wars movie, my kids and I, probably 1,000 times, so
Right.
I know them way too well. But I didn't think of this until you said this, but Rogue One, I think one of the things that was really sad about it, but I really made it really memorable, was when that robot sacrificed himself at the end to save the others. And you can think of, in Star Wars, all these times when we get attached to the robots, BB-8 and C-3PO and R2-D2, and how they seem emotionally so human. And I don't know what the point is about artificial intelligence, but I feel like so much of when we interact with artificial intelligence, we assign human qualities and emotions to it. Hopefully not always just screaming at your phone because it's not understanding what you're saying, but it makes me think a lot about the Star Wars movies.
Yeah, that's actually classic psychology, that we treat computers as human actors.
That we project.
Even before AI.
Project our feelings and emotions and ideas onto.
Yeah, that actually reminds me of the movie Her, which is, if I had to choose a movie, I would say probably the best depiction of AI. Where they're depicting an artificial assistant, and there's a lot of emotion going on there. And again, not so realistic. But I think that sort of building relationship with the artificial assistant, and it maybe understanding your voice better over time, and it sort of growing to understand your needs. I think that's not too crazy depiction of what AI can look like, and it definitely has that emotional angle that I think people are really trying for.
There was an article in the New Yorker a few years ago, I can't remember exactly when, but it was about elderly people, many of whom were unfortunately lonely, and they were given these pets, these kind of robot pets.
The seals.
Oh yeah, I don't remember what you remember better than I. Some animal.
Yeah.
and they knew they weren't real pets. They knew they weren't alive, but they really became attached to them, and it really helped them in a lot of cases, and they were doing better overall. Not didn't work for everybody, but it was it's exactly what you say. Now I kind of understand it more. So I think a couple things that I would want people to keep in mind about artificial intelligence. First, it's not just one thing. So as you were talking about before with natural language processing and using VR and recognizing images, there's lots of different types of artificial intelligence. And like you were talking about before, some of them work really well, some of them don't work really well. I think a big next step is figuring out how we get those different methods and tools to work together in a way that's really useful. So for example, humans, we were talking yesterday on Twitter about how humans synthesize all this information. So a physician might be seeing a patient and they're thinking about, okay, I know this from family history. This is what I'm seeing on physical exam. This is what I'm seeing on their x-rays. And I get some lab values over here. And maybe I get their genomic data over here. So humans are really good about pulling that all together. So far, at least in medical genetics, there are individual pockets that are really good, but I haven't seen an integration of these different methods in a way that works. And that's because it's really hard. I don't necessarily expect it to be right around the corner. But I think I'd like people to know that there's lots of different types of artificial intelligence. And a big task for those of us working in the field is tying those together in a way that actually helps people.
That's a really good point. And I think, we could sort of take a step back to sort of the data that goes in again. And I think it's really important probably for people to know that, there have been a lot of examples in the past of where bias has been baked in to AI and machine learning. And if a computer is learning from us and we have biases, or we tend to think of things in one way and give data that sort of only shows that. Sort of Oleg was talking about the rare diseases. If we mostly have seen them in people who look a certain way and maybe not in more diverse folks, then our models might not be trained to pick that up. So I just think keeping in mind that we have to make sure that what goes into the models, is not biased and is not going to cause all kinds of, potentially medical, social issues when it becomes implemented.
One of the most fascinating aspects of machine learning and artificial intelligence is, I think, it is the projection of our own human mind onto this space that is able to process a lot of zeros and ones. And I think, and that sort of goes back to what you said, because it is a projection of our understanding or perception of the world, but translated into numbers and formulas, which are now being able to be calculated with an extraordinary, amazing speed, I think it was important for us to think about how our biases, how our misunderstandings, how our limitations, when they are projected into that space, can undergo exponential growth. And while I think we have the ability to take full advantage of what artificial intelligence and machine learning can do for us and exponentially multiply good, we also need to think about just some of those negative aspects that I think we can also project into that space, can undergo the same transformation. And I think it's a constant tension there. And I think as we enter that sort of get past that inflection point, we need to be aware of that tension that can potentially grow and bring correct ideas and bring ideas that will benefit our patients and benefit our students to be healthier and become better persons.
That's great. And I think one piece going into that too is, as healthcare providers, as researchers, we use these data in really powerful ways, and can figure out all kinds of things about people and their health and their risk, and things like that. But the data don't just come to us, right? We kind of joke about it like, oh, such and such company has all my data. They do, and we probably want to be mindful about who has what data about us. And more, I know in my world of virtual reality, to use virtual reality, your body gets tracked on many points over time. And that can get fed into a model. It's thousands, millions of data points that can, how you're moving and how you might be moving over time as you use the same thing over and over. Who has that data? What can it predict about you? Just kind of food for thought as AI and machine learning are getting better and better and better.
Yeah, no, I think that's a great point. And I think we should emphasize all of us do different types of research with artificial intelligence. We have conversations with each other. We obviously talk to the participants. But a big part of the planning for all our studies is talking to people like bioethicists and the IRB, the folks that review the research plans that we do to make sure it's safe and effective and beneficial, and looking at risk benefits, and protecting data and using data in a good way, I think is a really important thing to emphasize.